Hypersonic aviation is quickly shifting from science fiction to reality thanks to bold innovators like Hermes. This American aerospace startup with strong government backing is developing technologies that could transform global travel. Central to their efforts is the Quarter Horse, an unmanned hypersonic aircraft paving the way for Halcyon, their future hypersonic passenger jet. The era of hypersonic flight is closer than you think. Hypersonic speeds, defined as Mach 5 and above, have existed in theory and practice for decades, although they have largely remained outside commercial application. The first real glimpse into hypersonic flight came in 1959, when North American Aviation's X-15 rocket plane achieved such speeds using rocket propulsion. Despite the groundbreaking nature of this milestone, rocket engines proved to be highly inefficient for long-range use. The primary issue was fuel consumption. Rockets required enormous amounts of fuel, up to 90% of the aircraft's total mass, leaving very little room for passengers, cargo, or advanced systems needed to ensure safety and reliability. This inefficiency made rocket-propelled aircraft impractical for commercial or reusable applications. However, in recent years, air-breathing propulsion systems like ramjets and scramjets have emerged as more viable solutions. These engines draw in oxygen from the atmosphere, allowing for a much more efficient fuel-to-thrust ratio. Their major limitation, however, is that they cannot function at low speeds, making them unsuitable for takeoff or landing without help from another propulsion system. Turbojets conversely perform well at low speeds and up to Mach 2, but are ineffective in hypersonic regimes. This technological divide has long hindered the dream of practical hypersonic aviation, the hybrid engine of the future. Hermes approached this challenge with ingenuity by creating a hybrid propulsion system named Chimera. This turbine-based combined-cycle engine integrates the low-speed efficiency of a turbojet with the high-speed capabilities of a ramjet, enabling seamless transition across a wide range of velocities. The name Chimera fittingly references the mythological creature composed of different animals, reflecting the engine's hybrid nature. During takeoff and landing, the Chimera functions as a traditional turbojet, providing the thrust needed to safely navigate runways. Once the aircraft reaches sufficient speed, it switches into ramjet mode, propelling the aircraft to hypersonic velocities. To manage the extreme temperatures associated with hypersonic airflow, the Chimera incorporates a pre-cooler system that reduces the temperature of incoming air before it enters the engine. This allows for higher engine efficiency and prevents overheating, a critical factor in achieving sustainable hypersonic flight. Perhaps the most impressive aspect of this development is the timeline and cost. Hermes managed to design, build, and test the Chimera engine in just 21 months, spending a mere $18 million, a remarkably low figure in the aerospace world. The Quarter Horse program, building momentum. The Chimera engine is the core of Hermes' Quarter Horse program, an unmanned aircraft initiative designed to validate the technologies needed for future hypersonic travel. The development roadmap includes 4 prototype versions, Mk0 through Mk3, each targeting specific milestones. These aircraft are not just scaled-down experiments, they represent real-world tests that bring Hermes closer to full-scale hypersonic capability. In early 2024, Hermes completed tests on the Mk0, a ground-based platform built to evaluate system integration, remote operation, and basic control functionalities. This prototype was constructed in just 6 months and underwent comprehensive testing at the Arnold Engineering Development Complex in Tennessee. Over the course of just 37 days, it successfully met a range of objectives, including remote control operation, communications latency evaluation, and system behavior during loss-of-link scenarios. This initial success demonstrated the viability of Hermes' systems architecture and development process. The next iteration, Mk1, took flight testing even further. Completed by March 2024, this prototype focused on autonomous takeoff and landing capabilities. Built in 7 months, Mk1 underwent testing at Edwards Air Force Base, culminating in full afterburner taxi tests at speeds up to 50 miles per hour. It was powered by the General Electric J85 engine, previously used in lightweight military jets like the F-5 Freedom Fighter and the T-38 Talon. Although not designed to break speed records, Mk1 laid the foundation for more complex and faster vehicles to follow. Mk2 and Mk3, breaking the sound barrier and beyond. Currently under construction in Atlanta, the Mk2 prototype represents a significant leap forward. It will feature a more powerful engine, the Pratt & Whitney F100, the same engine that powers the F-15 Eagle and F-16 Fighting Falcon. This version is expected to break the sound barrier and demonstrate autonomous supersonic flight up to Mach 3. While Hermes has not released detailed specifications for Mk3, its role is even more ambitious: to demonstrate in-flight transition between turbojet and ramjet modes, and to break the SR-71 Blackbird's airspeed record of Mach 3.3. Material challenges at Mach 5+. Achieving speeds above Mach 5 introduces enormous thermal stress on an aircraft's body. Temperatures can range between 1,000 degrees Fahrenheit and 3,600 degrees Fahrenheit, requiring materials that can withstand extreme heat without compromising structural integrity. Hermes considered several advanced materials, including titanium, nickel alloys, and carbon ceramic composites. While nickel-based superalloys offer excellent heat resistance, they are heavy and not ideal for full airframe construction. To address this, Hermes leveraged 3D printing technology using industrial-grade Velo 3D Sapphire and Sapphire XC printers. These machines were calibrated to print complex engine parts using Inconel 718, a nickel-chromium alloy capable of withstanding temperatures up to 1,300 degrees Fahrenheit. This approach allowed the team to build precise, durable components at lower cost and with faster turnaround times. Most of the aircraft's structural body remains constructed from titanium, offering a balance between weight and heat resistance. The design of Quarter Horse, with its razor-sharp nose and streamlined body, draws visual inspiration from the legendary SR-71, offering both aesthetics and aerodynamic performance. Test control in the harshest environments. Managing such high-speed, high-risk tests requires a sophisticated control system, which Hermes has developed in the form of a high-performance computing center, HPCC. Externally resembling a standard transport container, the HPCC serves as a fully functional mission control center capable of remote operation. Inside, the center houses dedicated seats for a pilot, payload operator, and operational analysts. It is equipped with climate-controlled environments to protect sensitive electronics and can be deployed anywhere in the world, offering full off-grid capability for testing in austere locations. What comes after Quarter Horse? Meet Dark Horse. Following the Quarter Horse, Hermes is developing a larger, more advanced hypersonic aircraft called Dark Horse. While Quarter Horse is primarily a testbed, Dark Horse is intended to serve practical military and defense applications. It will feature enhanced reusability, increased payload capacity, and the same hybrid engine capabilities, allowing it to meet a wider range of operational needs. This aircraft is a crucial intermediate step toward Hermes' long-term commercial goal: Halcyon, the hypersonic passenger jet of tomorrow. The true culmination of Hermes' efforts is the proposed Halcyon, a hypersonic passenger jet designed to transform global travel, capable of flying over 125 transoceanic routes. Halcyon would reduce the flight time from New York to London to just 90 minutes. In contrast, traditional airliners make the same journey in over 7 hours. The first flight of Halcyon is currently scheduled for 2029, but before that can happen, the company must complete successful tests of the Mk2 and Mk3 prototypes by 2025 and 2026 respectively. Though many challenges remain, including certification, safety validation, and international regulatory approval, Hermes has shown a remarkable ability to move quickly, develop complex systems affordably, and meet milestones that would normally take years in the aerospace industry. If they continue on this trajectory, hypersonic commercial flight might very well become a reality within the next decade. And that wraps up our deep dive into Hermes and the incredible Quarter Horse hypersonic aircraft. If you enjoyed this video and want to stay updated on the latest breakthroughs in aerospace and tech, make sure to give this video a like, subscribe to the channel, and hit that notification bell so you never miss an upload. Thanks for watching, and we'll see you in the next one.